In this video, we're going to learn how to solve this quite interesting math problem. It is actually quite challenging, therefore I'm going to discuss two possible solutions. Alright, the first one using what we call relative or net speed, and the other using ratio. Dean and Sabine started running around a track that is 11 kilometers long. Right? They started at the same point but went in opposite directions. Dean's speed was a constant 6 km per hour and Sabine's speed was a constant 9 km per hour. Part A, how long in minutes did it take for them to meet each other? And part B, how far has Dean ran when he met Sabine? But before we try to solve the problem, I would like to show a small animation of it. Alright, so let's take a look at this. Right, so that is where both of them meet. Right, Dean is traveling at 6 km per hour, whereas Sabine 9 km per hour or faster. As you can see, when they meet, the distances covered by both of them will add up to the total distance of the track itself. Right, so that is the first fact we can see here. And the second fact is that when they meet, the time of travel for Dean is also equal to the time of travel for Sabine. The first solution that we're going to learn is to make use of what is known as net or relative speed. Right, so let's take a look at this simple animation. Right, so as you can see here, there are two objects A and B. Right, so let's start by making both of them having the same speed of 1 unit. Right, and let's see what happens. As I increase the time, both of them, because they say they have the same speed, all right, they remain at the same point with each other. Right, so therefore the net speed, or what we call the relative speed between A and B, is actually 0. It is as if with respect to each other they are not moving at all. Right, so let's repeat this. B now has a speed of 2 in the same direction, and let's see what happens. Right, so as you can see, B is now in front. All right, but relative to A, right, because A is moving, B speed is not 2 units. All right, you can see here the speed, the net speed is equal to the net distance divided by the time. All right, as you can see, when I increase the time, right, the distance between them also increases. And you can see that it always gives you a speed of 1. Right? And then this one can also actually be obtained by taking the speed of B minus the speed of A. 2 minus 1 equal to 1. Right? So let's try a third example. We're going to increase the speed of B to 3, and using the formula, all right, the relative speed or the net speed will be 2. Right? Let's see the simulation. Right, that's time 1. The distance between them is 2. Right, why 2? Because B speed is 3, whereas A speed is actually 1. Right, so 3 minus 1 is 2. At time 2, right, how do we get 4? It is 4 because 3 times 2 is 6, and then 1 times 2 is 2. So we have 6 and 2. Therefore, the distance between them is actually 4. All right, but the time is 2. So 4 divided by 2 will give us still 2. And lastly, at time 3, how do we get 6? Because 3 times 3, 9, minus 1 times 3, 3. Therefore, it is 6, and 6 divided by 3 will give us 2. Right? So that is the case in which they are both traveling in the same direction. Right? The interesting part will be this. What happens if they are traveling in the opposite direction? Let's start with having both of them. Both with speed of 1. Right? So can you see this? They are traveling in the opposite direction. Even though their speeds are both 1, but the distance between them will be 2, right? Because they are in the opposite direction. Right, so the net speed is actually not finding the difference but adding them up. 1 plus 1 is equal to 2. Right, so you can see here the net distance is 2, time is 1, we get 2 here, and then when I increase it to 2, right, the distance between them is now 4. 4 divided by 2 is still 2. Finally, at time 3, the distance is now 6. Right, 6 divided by 3 is equal to 2. Right, so last one, perhaps let's increase both of them to the speed of, let's say one of them is 2 and B speed to 3. Right, so time 1. Right, how do we get 5? Quite obvious, right? Because B speed is 3, 3 times 1 is 3, and then 2 times 1 is 2. We have to add them together instead of minusing them. Right, so we have 5. 5 divided by 1 is equal to 5. Times 2 is 10, and finally at time 3 is 15. So now we can try to solve the problem using the concept of relative speed. Right, Dean's speed is 6 km per hour. Sabine's speed is 9 km per hour. Right, now since they are traveling in the opposite direction, all right, the net speed will be the addition of both, right, as we have seen in the animation. So 9 plus 6 is equal to 15 km per hour. Right, the entire track is 11 km. So to find the time, you just need to take the total distance divided by the speed, and since the question asks for the answer in minutes, we have to multiply by 60. Right, so we're going to get 44 minutes. That's the answer for part A. So now let's answer part B. Part B will be quite simple. How far has Dean ran when he met Sabine? Alright, the time is 44 minutes, which is common for both. Alright, and then Dean's speed is 6 kilometer. Alright, to find the distance, we just have to take the time multiplied by the speed. Right, so time is 44 minutes, right, but we have to divide by 60 because the speed is in kilometer per hour, and Dean's speed is 6 kilometer per hour. Right, so we're going to get 4.4 kilometers. In the second solution, we are going to make use of ratio to solve the problem. Right? If you were to remember the simulation that we did at the early part of the video, right? When both of them meet, the time taken is the same for both Dean and Sabine. Right? So if you were to take the formula, distance is equal to time multiplied by speed. Right? If the time is the same for both, that means the distance will only depend on the speed. Right? So if you were to take the ratio of Dean's distance to Sabine's distance, right, this will be the same as taking the ratio for Dean's speed to Sabine's speed. Right? So this will be equal to 6:9. Right? So we can simplify this. We divide by 3. We're going to get 2:3. So the ratio of the distance traveled by Dean and Sabine is actually 2:3. Right? So now we have 5 units equal to 11. All right, so we are interested in finding 2 units. So 2 units will be equal to 2 divided by 5 times 11. Right, so we are going to get 4.4 kilometers. Right, so in this method, actually we are finding the answer to part B first. Right, so it's different from the first solution, in which we can follow the order of the question. All right, so now having found the answer for part B, which is the distance that Dean ran, we can easily find the answer for part A. Right, so for part A, we need to find the time taken. So the time taken is equal to distance divided by speed. Right, distance is 4.4 kilometers and speed is 6 for Dean. All right, since we want the answer in minutes, we have to multiply by 60. Right, so we're going to get 44 minutes. So now that you have learned how to solve this problem, right, it is very important that you follow it up with some practice. Okay, so go to the link that is given below, click on this new problem button. All right, you will have a different set of numbers to test yourself. All right, then you can check. All right, it's really up to you which method you want to use. Right, the first method is making use of the concept of relative speed, whereas the alternative answer is making use of ratio. I hope we have learned something new in this video. All right, have fun and thank you for listening.